Welcome learners. In this video lecture we are going to discuss moments. The learning objective of this lecture is to learn about definition of moments and different kinds of moments that are non-central and central moments. The relationship between raw moments and central moments. We are expressing central moments in terms of raw moments. We are going to derive the relationship between raw moments and central moments also. Let us define moments. Moments are statistical averages. The moments are a set of statistical parameters to measure a distribution. Generally, there are four. In general, we use first four central moments to describe all the distributions. Moments are of two types. They are non-central moments and central moments. These central moments are also called moments about mean. The raw moments or non-central moments is defined as the rth moment about any point A is called non-central moment. It is usually denoted by mu or dash. The rth moment is denoted by mu r dash and it is given by mu r dash is equal to 1 by n summation I is equal to 1 to n fi xi minus a power r. This is the rth non-central moment about point A. Here summation I is equal to 1 to n fi is nothing but total frequency capital N. This is the definition for rth non-central moment. Let t is equal to x minus a. Then substitute it in the definition of non-central moment, rth non-central moment. I is equal to 1 to n fi xi minus a power r by n is the definition of rth non-central moment. Substitute instead of x minus a d here. So mu r dash is equal to I is equal to 1 to n fi instead of xi minus a we substitute d here, that is d power r. We can write like this also where d is equal to xi minus a. Suppose if dA is equal to xi minus a by c, then mu r dash is equal to I is equal to 1 to n fi dA power r by n into c power r. Generally, we use this formula to calculate first four non-central moments, and then by using the non-central moments, generally we calculate central moments. If r is equal to 1, mu1 dash is equal to sigma fi di by n into c, and mu2 dash is equal to I is equal to 1 to n sigma fi di square by n into c square. Mu3 dash is equal to I is equal to 1 to n fi di power 3 by n into c power 3, and mu4 dash is equal to I is equal to 1 to n fi di power 4 by n into c power 4. For all practical calculations to find raw moments, first for raw moments we use this calculation only. And if we take the arbitrary point a is equal to 0 in this formula, if we put a is equal to 0, then the raw moments are called moments about origin. They are called moments about origin if a is equal to 0. The rth moment about origin is given by just simply put 0 here. This vanishes. fi xi power r. Mu r dash is equal to I is equal to 1 to n fi xi power r by n is the rth raw moment about origin. Similarly, if r is equal to 1, mu1 dash is equal to, keep substitute r is equal to 1 in this formula. Mu1 dash is equal to I is equal to 1 to n fi xi power 1 by n. Think but this is our mean. sigma fi xi by n is the first raw moment about origin. Similarly, this is mu2 dash fi xi square by n. mu3 dash is equal to I is equal to 1 to n fi xi power 3 by n. Also mu4 dash is equal to I is equal to 1 to n fi xi power 4 by n. These are the first 4 raw moments about origin. Next is central moments or moments about origin. The rth moment about mean x bar is called the central moment, whereas the rth moment about arbitrary value a is called non-central moments. Instead of a, we are using x bar here. It is denoted by mu r, not dash here. Mu r is the notation for central moment. The rth central moment is given by 1 by n into I is equal to 1 by summation I is equal to 1 to n fi xi minus x bar power r. Here n is equal to total frequency. If r is equal to 0, the keep r is equal to 0 in central moments, rth central moment. Substitute 0 in the place of r, mu 0. 1 by n, I is equal to n to n fi xi minus x bar power 0. This is equal to anything power 0 must be equal to 1. This is I is equal to 1 to n fi by n. Here, look here, I is equal to 1 to n fi xi, I is equal to 1 to n fi is n here, n by n is equal to 1. So, mu 0 is equal to 1. Put r is equal to 1 in the formula. That is first central moment. This is the rth central moment. Keep substitute r is equal to 1 in the formula. mu1 is equal to 1 by n, I is equal to 1 to n fi xi minus x bar power 1. 1 in the place of r. I is equal to 1 to n fi. Take this into inside. Multiply these two factors with summation I is equal to 1 to n fi by n. 1 by n, I is equal to 1 to n fi xi minus 1 by n, I is equal to 1 to n. This term multiplies both xi and x bar. Here, this is nothing but x bar. This is nothing but summation I is equal to 1 to n fi xi by n is nothing but x bar. And look here, this is n by n is 1. So this is x bar and this is also x bar. X bar minus x bar is equal to 0. So first central moment is 0 always. Look here, substitute r is equal to 0, mu2 is equal to 1 by n, I is equal to n to n fi xi minus x bar whole square, nothing but sigma square. mu2 is equal to sigma square, that is second central moment is variance. If d is equal to xi minus a, multiply with this term, both left hand side and right hand side, multiply with I is equal to 1 to n fi by n. This is n by n is equal to 1. Multiplying with 1 on both sides changes nothing. di I is equal to 1 to n fi, I is equal to 1 to n fi by n into di. Here also I is equal to 1 to n fi by n into this term. This is nothing but mu1 dash. This is first non-central moment. mu1 dash is equal to I is equal to 1 to n fi into xi by n. Similarly, I is equal to 1 to n fi a. Here a by n. So I is equal to 1 to n, Fi is n by n gets cancelled, a remains here. This is x bar. Look here, this is x bar. So mu1 dash is equal to x bar minus a. Also x bar is equal to a plus mu1 dash. We can use, instead of x bar, we can use a plus mu1 dash. This is, you remember, this is a plus sigma fd by n. Deviation method to calculate x bar. So this is, we are using as sigma fd by n as mu1 dash. First non-central moment. Let us derive the relationship between central moments in terms of non-central moments. By the definition of central moments, we know that mu r is equal to 1 by n into I is equal to 1 to n fi xi minus x bar power r. This is the definition of rth central moment. I am just subtracting a and adding a to this term. The remaining are same here. 1 by n I is equal to 1 to n fi xi minus a plus a. Okay, just keeping brackets here. This is one term and this is another term. Okay, here this becomes d. Here di is equal to xi minus a. Look here, we already know mu1 dash is equal to x bar minus a, or x bar is equal to a plus mu1 dash. Multiply with minus 1 on both sides. What happens? This becomes minus 1. Okay, this becomes minus 1. Minus a becomes plus a. Plus x bar becomes minus x bar. So instead of a minus x bar, we can write minus mu1 dash. Okay. Instead of this term, we can use minus mu1 dash. We assume x minus a as d. So this is this term. This term becomes 1 by n into I is equal to 1 to n fi di minus mu1 dash whole power r. You are all know the binomial theorem. Binomial theorem, x minus a. Generally we are using x plus y. X minus y power r is equal to rc0 x power r y power 0 minus rc1 x power r minus 1 y power 1 plus rc2 x power r minus 2 y square. Rc minus, alternatively minus comes. Okay, rc3 x power r minus 3 y cube plus so on minus 1 power r rcr x minus r becomes 0 here. This term vanishes, y power r. Here also this term vanishes. Apply this binomial theorem for this term. Instead of di minus mu1 dash. Here x is equal to d here and mu1 dash is equal to y here. Just replace, instead of x di and instead of y mu1 dash. 1 by n I is equal to 1 to n fi remains here. Instead of this term, binomial expansion. I kept bracket here, square bracket here. rc0 x power r. Second term vanishes. Instead of x, di here. di power r. rc1 di power r minus 1. Second term comes here. mu1 dash plus rc2 di power r minus 2. mu1 dash power 2. rc3 di power r minus 3. Second term is, instead of y, mu1 dash power 3, so on, minus 1 power r. This term vanishes. Second term is mu1 dash power r. This is the expansion of this term. Okay. Look here. This rc0 comes here. Take summation I is equal to 1 to n fi by n inside the square bracket. Multiply this term with all the terms. RC0 becomes 1. RC0 1 by n summation I is equal to 1 to n only di power r. 1 by n I is equal to 1 to n fi di power r minus RC1 constants coefficients into 1 by n I is equal to 1 to n fi into di power r minus 1 into mu1 dash plus RC2 into 1 by n into I is equal to 1 to n fi di power r minus 2 here into mu1 dash whole square, mu1 dash square minus RC3 1 by n into I is equal to 1 to n fi di power r minus 3 mu1 dash 3 mu1 dash cube plus so on plus minus 1 power r this term 1 by n into summation I is equal to 1 to n fi into last term mu1 dash power r. Okay, so this becomes 1 here, this becomes r, this becomes RC2, this is RC3 and this becomes 1. So finally this is the relationship. Mu r is equal to rth central moment in terms of raw moments is, look here, 1 by n I is equal to 1 to n fi di power r, nothing but the first raw moment. Look at the definition again. Okay, look here, mu r dash is equal to, when di is equal to xi minus a, mu r dash is equal to I is equal to 1 to n fi di power r by n. Instead of this term we can use mu r dash. If here r minus 1, if here r minus 1, this becomes r minus 1. If here r minus 2, this becomes r minus 2. So this is mu r dash, and look here, I is equal to 1 to n fi di power r minus 1. This is nothing but mu r dash. Here this is nothing but mu r minus 2 dash, mu r minus 2 dash. This is mu r minus 1 dash. This is this term, mu r minus 3 dash. Okay, instead of this we can use mu r dash. Instead of this we can use mu r minus 1 dash into mu1 dash. Here RC1 is nothing but 1. RC1 is nothing but r. RC2 mu r minus 2 dash mu1 dash whole square. Here RC3 into, instead of this we can write mu r minus 3 dash mu1 dash whole cube, so on, minus 1 power r. This is 1 mu r dash moments. So this is the relationship between raw moments and central moments. By using this relationship we can calculate first 4 central moments in terms of raw moments. Let us look at the calculation of first 4 central moments in terms of raw moments. This is the relationship. Substitute r is equal to 2 here. Keep, whenever r, keep 2 there. Mu2 is equal to RC0. I kept RC0 here. 2C0 mu2 dash minus 2C1 mu2 minus 1 mu1. Here 2 minus 1 mu1 mu1 dash 2C2 mu2 minus 2 becomes 0 mu0 dash mu1 dash whole square. Okay, the remaining terms vanishes because for 3 terms only comes. In binomial expansion you remember x plus y is x plus y power 1 is equal to x plus y. X plus y power 2 is equal to 3 terms. Okay, if cube is there, 4 terms comes. So for 2 only 3 terms comes. The other terms vanishes. So up to 2ct only come. Mu2 is equal to 2c0 1 here. Mu2 remains 2c1 2 mu1 dash into mu1 dash mu1 dash into mu1 dash 2c2 is nothing but 1 mu0 dash is equal to 1. We are already seen that mu0 is equal to 1. Look here, mu0 is equal to 1. Both central moments and raw moments also. This holds good for raw moments also. Okay, mu0 is equal to 1 always. So this mu0 becomes 1. Look here, mu2 is equal to mu2 dash minus 2 into mu1 dash into mu1 dash square plus this becomes 1 and mu1 dash whole square. So here 2 mu1 dash squares, 1 mu1 dash square. So this becomes minus and minus sign here. So 2 minuses and 1 plus. So 1 minus remains. Minus 2 mu1 dash square plus mu1 dash square, that gives us minus mu1 dash whole square. So mu2 is equal to mu2, second central moment is equal to mu2 dash minus mu1 dash whole square. Put r is equal to 3 in this expansion. Mu3 is equal to 3c0 mu3 dash 3c1 mu2 dash mu1 dash plus 3c2 mu1 dash square mu3 cube. This is in the formula minus 3c3, this mu 3 minus 3 0 mu1 dash whole cube here. This is simply 1 into mu3 dash 3c1 3 mu2 dash mu1 dash plus 3c2 also 3. This is mu1 dash whole square. This 2 becomes multiplying these mu1 dash here, square not there, square not there, mu1 dash into mu2 dash, and 3c3 is 1 here. This is 1 mu1 dash whole cube. This becomes, look here, here it is correct, this is not correct, and here 3c0 1 mu3 dash 3c1 3 mu2 dash into mu1 dash plus 3c2 3 mu2 mu1 square. Look here, 3c2 r minus 2 3 minus 2 mu1, here mu1, this mu1 and mu1 square mu1 cube minus mu1, this becomes 1 and this becomes 1 mu1 dash whole cube. So mu3 is equal to mu3 dash minus 3 mu2 dash mu1 dash plus 2 into mu1 dash whole cube. Okay, this is wrong, this is correct, this is correct. Okay, this is wrong. Yeah, for this 1, for this 2. Okay, put r is equal to 4 in the form. Mu4 is equal to 4c0 mu4 dash minus 4c1 mu3 dash mu1 dash plus 4c2 mu2 dash mu1 dash whole square 4c3 mu1 dash 4c3, next term 4c3 mu 4 minus 3 mu1 dash whole cube plus 4c4 4 minus 4 0, and this is mu1 dash whole power 4. Okay, this is equal to mu 4 dash 4 mu 3 dash mu 1 dash 6 mu 2 dash mu 1 dash whole square plus minus 4 mu 1 dash into mu 1 dash whole cube plus 1 into mu 0 mu 1 dash whole power 4. Okay, this is nothing but this is mu 4 dash 4 into mu 1 dash into mu 3 dash into mu 1 dash 6 mu 2 dash mu 1 dash whole square minus 4 mu 1 dash whole power 4 plus this becomes 1 mu 4 dash whole power 4. Here we have 4 1 mu 1 dash whole power 4. Here 4 mu 1 dash whole power 4 becomes minus 3 mu 1 dash whole power 4. Okay, this is mu 4 dash 4 mu 3 dash mu 1 dash plus 6 mu 2 dash into mu 1 dash whole square here 4 also here. Okay, this is correct. So these are the first 4 central moments in terms of raw moments. mu1 first central moment is 0 always. This is the second central moment, this is the third central moment, and this is the fourth central moment. There are some corrections here it is varying. Okay, similarly we can derive the non-central moments in terms of central moments also. There is another concept, effect of change of origin on moments and Shepard's correction, uses of moments, discuss in the next lecture. Thank you.